this subject is called rationalizing substitution. So which means a substitution which manages to rationalize things. That is to say that originally the integrand contains some sort of square root, and then your intent is to make a change of variable such that after the change of variable, you have something which is square root, or in general, it doesn't have to be square root, it could be cube root, right? In general, radical free of radicals. And so the example that I'm going to give you is taken from the book. And this one is problem number 40, the next page. And it goes like this. So this is our first example. And at first it could look intimidating because of the presence of square root. And because the square root doesn't appear in one of those three ways that we talked about in the previous sections when we talked about trig substitution, right? So this is not certainly one of those type of problems. And the integrand looks like this. The denominator has two terms. The second term is x, and the first term is 2 times the square root, underneath which you have x plus 3. Anyway, I've never dealt with this kind of problem, right? So there is a square root, which is kind of annoying, and the substitution that we're going to introduce manages to get rid of the square root somehow. So here is a magic substitution. All right? So it goes u equal to, let u be square root x plus 3. And in this kind of rationalizing substitution, you'll find it beneficial if once you write it this way, introducing the u, right? You square both sides to make things easier. So I'm going to square both sides, so u squared is equal to what? X plus 3. And then only after that, you d both sides. D both sides. Could you help me with that? So I'm going to d the left, d the right. The right-hand side is easier. What is that? dx. And left-hand side, if I d it, if I take the differential, what is that? 2u du. And let's see if you play around with this kind of rationalizing substitution, which is usually of that form, u equal to cube root and square root or whatever, something the key part of the integrand that has the radical, annoying radical. And sometimes you do it this way. And let's see if it works. So so we look at we do this substitution. So this one becomes, this one is indefinite integral. Otherwise, you have to, change the limit and integration as well, right? But anyway, this one is indefinite integral, so I don't have to worry about that. So what is dx? Isn't that 2u du? That's that piece. This one is 2 times square root, but that square root is what we call u, right? And then plus, what is x? This one, x therefore is u squared minus 3, correct?
Yes.
Okay, so this is u squared minus 3. Should you be happy now? Isn't this more familiar territory? Right? So this one becomes 2u du, and then this one is u squared, oops, sorry, u squared plus 2u, rearranging it, would yield this, right? That's the denominator, and we can easily factor this one, correct? Right? Yeah. And so this becomes u plus 3, u minus 1 as the denominator. And then this one can be written as u minus 1 and u plus 3, right? Something, something, correct? du, right? And you just play with it. You can formally call this A and call this B and do the thing that you would do, right? If I call this A and B, and then one approach to it is, you know, this 2u over u plus 3u minus 1 is equal to A over u minus 1 plus B over u plus 3. If I multiply both rational expressions by u plus 3u minus 1, then on the left I have 2u, on the right I have A times u plus 3 plus B times u minus 1, correct? And then I'm not going to match the coefficient. This one I probably would be better off just plugging number, right? So let u be, for example, 1, and that will kill this one. And I'm left with this guy, which is 4a. 4a is equal to what? 2u, that means 2. So a is 1/2. Is that right? Correct? And then, and let u be, if instead you want to kill this guy, then you let u be -3. So -6 therefore is equal to this one is gone. -4, -4b, correct? And so what is b? 3/2. And so I continue over here, and I said that, okay, this one is equal to a is 1/2 u minus 1 plus b is 3/2 u plus 3. Oh, yeah, that's right. bu, right? That's it. Or you could, you know, in this kind of cases where you have just two linear factors with power 1, sometimes you you know, build on your experiences, actually can bypass this and actually, you know, just guess. You know, I would right here I would guess that you see that if you have this plus this, then this is equal to denominator this times this, and the numerator is a times this plus b times that, right? And then if the numerator eventually I want to see 2u, then I'd better make sure that the constant term can cancel out. But a is going to cross multiply. This is going to multiply by 3, and this is going to be multiplied by -1. So I better make sure that b is 3 times as big as a. And therefore, one thing to try is 1, 3. But if you do 1, 3, then you manage to have no constant term. That's fine, but you will get, you know, 2u. Sorry, you'll get 4u as opposed to 2u. So that's too big, and therefore you divide through by 2, and therefore you get something like this. All right, so depends upon your confidence level. Do whatever you need to do, so long as the answer is correct. All right, and so once you get to here, then I know that this is 1/2 natural logarithm u minus 1 plus 3/2 natural logarithm u plus 3. And the rest is more or less mechanical. And then plus integration constant. And just recall what u is. Okay, u is square root x plus 3, and then minus 1, that's one piece, plus 3/2 natural logarithm square root of x plus 3, and then plus 3. And then plus integration constant. And that's the answer. So this is called rationalizing substitution. So it's a substitution that manages to rationalize the integrand. That's what it means. To make it free of radicals, free of square root or cube root or any kind of root. So let me give you another problem, which is even more horrible.